There are times in life where we deal with amount functions and times where we deal with what we call rate functions. An example of this would be position and velocity. Okay, I could, for example, decide I'm going to take my position from this wall at various locations as I move away or toward the wall. That would represent position as a function of time. Now, if I look at the way in which my position changes over time, I would call that a rate function, or in this case, we would call it velocity. What you're going to do with this game is you're going to take the randomly generated graph that's on your screen, and you're going to approximate the rate of change of it at various locations, all the different integer values, -6, -5, -4, and so on, up to 6 across here. And what you're going to do is you're going to then move these points that are stitched together, these little dots, into position so that they represent what we would call the rate function or the slope function. Another way to think of this would be a slope of this particular curvy graph at a given location. So for example, what you can do is you can take a straight edge of any kind. I'm going to use just a folder here as an example. And let's say at -6, I go up here and I say, that's got a steepness of about that. Okay, and so I can look and approximate that. Here, if I go over 1 unit this way, I go up about, I would guess I go up 1 and maybe a third, let's call it 1.3. I'm going to go up 1.3. So in this case, I would just compute that. So I could say my rate of change, my y change in this case, would be about 1.3 over 1, which of course is 1.3. So what I would do then is I would move this into location here of 1.3. So I'm going to move this up to about 1.3-ish. There. And then I would do the same thing, for example, at -5. I could take a look there, and I could say, all right, if I go over 1 unit, I'm going up maybe about 0.5-ish. So we'll say that's a slope of about 0.5. And of course, you can have negative slopes and so on here. So I'm going to move this one up to about 0.5 there. So the y coordinate in this function is representing the slope of this function. Okay, and we'll continue to do that all the way across. So here it looks, and I'm just going to guess a few just to kind of give you the idea. This one here would be at this location would be a negative slope. It's going downhill, so I'm going to make it negative. I'm just going to guess it's somewhere around there. Okay, this one here, again, if I go to this graph, it's negative, so therefore it's going to be negative. It's going to be a little more negative than the previous one because it's going downhill a little bit steeper. And I continue to do that. So this one here, still in the negative zone. Let's say it's about there. And again, I'm just making these up. You'll actually do some computations as you go. This one here, still in the negative slope zone, but not quite as negative as before. All right, here, I'm going to guess it's maybe about there. Somewhere, maybe right around there. This one here. I'm now into the positive slope zone. So I'm going to guess it's maybe there. And then this one here, still positive. Let's say it's about there. The next one, still positive, but not quite so positive. So let's say it's maybe about there. I'm going to move this guy down just a little bit. And then this one here, he's now on the downhill slope right here, so he's kind of negative still. Not super steep, so I'm going to leave him right about there. Let's see, this one here is negative, but it's more negative than the previous one. And then this one here is even more negative still. So I'm going to put it down there. I'm just guessing it's something like that. So let's just say that's my initial guess. And then I can take and click down here on check accuracy and see how good it is. It says I got a 78% accuracy. If I want to show the results, I can click here, and there is the red one is the actual slope function of the original. So you can see shape-wise I'm pretty good, but I was off a little bit. And again, I was guessing. You're going to be actually doing some computations as a way to get a more accurate approximation. Your goal, it says final accuracy 78%, not bad. Your goal is to get your accuracy as high as possible, as close to 100% as possible. The person who gets the highest accuracy wins the prize. In this particular case, we are going to be giving a TI Nspire CX2 CAS as the prize. So this is an individual activity. Approximate it, do your best, see what you come up with.